Good evening, all of you. So as we completed complete physical chemistry from first PU, so I'm starting in organic chemistry, that is hydrogen its compounds. Okay. So let us see hydrogen and its compounds. So after this, again, I'll go back to organic. I'll finish. Okay. Hydrogen's compounds. One question will come from this chapter. Let us see. Now, in this first case, let us see isotopes of hydrogen. Isotopes of hydrogen. Now, in this, we have three isotopes, H11, H12, H13. H11 is called protium, H12 is called deuterium, H13 is called tritium. Okay, tritium is radioactive. Tritium is radioactive. Okay, the next point, position of hydrogen. Position of hydrogen. It resembles, actually hydrogen, it resembles with both alkali metals as well as halogens also. Okay, now if you consider alkali metals, hydrogen resemblance with alkali metals, like it can form uni-positive ion like alkali metals like Na plus, K plus, like that. This is first one. Then it acts as good reducing agent like alkali metals. It acts as a good reducing agent like alkali metals. Whereas halogens, it can form uni-negative ions like halogens, that is Cl minus, Br minus, and H minus is formed by gaining one electron. How halogens gains one electron, it is also able to gain one electron to get inert gas configuration. And like halogens, its ionization potential is very high. Okay, like halogens, its ionization potential is very high. But the only reason why it is placed in first group, that is in alkali metals, its electronic configuration. So NS1. So this electronic configuration resembles with the electronic configuration of alkali metals. That's the only reason. This is about position of hydrogen. Next, preparation of H2. So we have several methods. In that, some important methods only we will see, that is from acids. If you take zinc, when it is treated with H2SO4, sulfuric acid, gives zinc sulfate plus hydrogen gas. From magnesium, if you treat with nitric acid, then you will get magnesium nitrate plus hydrogen gas. So from acids we can prepare. Similarly, from alkalis, bases, zinc plus 2NaOH gives rise to Na2ZnO2 plus hydrogen gas. So this is what we call sodium zincate. Sodium zincate, right? Next method, from natural gas. So let us suppose it is methane. So CH4 on passing with steam. This is gas. Then you'll get a mixture of CO and H2. Now, mixture of carbon monoxide and hydrogen gas is called water gas. What it is called? Water gas or syngas or blue gas. So mixture of CO and H2. Okay. So these are some important preparation methods of dihydrogen. Next, chemical reactions are there, but not so important chemical reactions of hydrogen. So next topic is about hydrides. Let us see what are hydrides. So generally these hydrides are divided into three types. Let us see one by one. The first one, ionic hydrides. Ionic hydrides. What are ionic hydrides? Ionic hydrides are formed by, they are formed by first A and second A group elements. First A, second means alkali and alkaline earth metals. Alkali and alkaline earth metals. Example, lithium hydride, magnesium hydride. Now CaH2 is known as hydrolith. CaH2 is known as hydrolith. Next, second type, covalent hydrides. Covalent hydrides. In this, three types are there: electron precise hydrides, precise hydrides. So these are formed by 14th group elements like SiH4, is it? SiH4, CH4, they are electron precise, formed by 14th group. Next one, electron deficient hydrides. What are they? Aluminum hydride, arsenic hydride. They're electron deficient. That means which group elements? 13th group elements. Last one, electron rich hydrides. So these are formed by 15th, 16th and 17th group elements. Example, you take any 15th, PH3, 16th, H2O, 17th, HF. So all these are electron-rich hydrides. Electron-rich hydrides. This is second type, covalent. Third type, interstitial hydrides. Interstitial hydrides. Example, titanium hydride, TiH2, 1.67. So these are non-stoichiometric hydrides. Non-stoichiometric hydrides, right? So this is about hydrogen. Next. H2O2, hydrogen peroxide. Hydrogen peroxide. Preparation methods. From barium peroxide, BaO2, when it is treated with carbon dioxide and water, then you will get H2O2 and barium carbonate. So this is our target molecule, right? Next, by electrolysis of 50% H2SO4 solution. By electrolysis of 50% H2SO4 solution. So this is one industrial method. This is industrial method. Then one more method is the auto-oxidation of 2-ethyl anthraquinol. 2-ethyl anthraquinol, right? So that means 2-ethyl anthraquinol on oxidation is converted into 2-ethyl anthraquinone plus hydrogen peroxide. This is what you will get. So this is about preparation methods of H2O. Done? Then next, chemical properties. Chemical properties of hydrogen peroxide. So inorganic chemistry is pure theory part, right? So you need to study NCERT textbook as many times as possible. Okay. First, let us consider its oxidizing action. So oxidation properties. In that first one, lead sulfide, which is in black color. When it is treated with hydrogen peroxide, you will get white colored precipitate. What you will get? White colored precipitate lead sulfate plus water. So white colored black lead sulfide, black lead sulfide is oxidized to lead sulfate, white colored precipitate. Next. If you take any colored material on treatment with hydrogen peroxide becomes colorless. K2Cr2O7 in presence of H2SO4 plus hydrogen peroxide. So it is giving a oxidized product, which is peroxide of chromium. Yesterday we have seen its structure. Now it is a blue colored compound, right? Next, let us see reduction properties. Reduction properties. So what are reduction properties? Okay, let's see one by one. First one, it reduces Az2O to silver. How? Az2O, when it is treated with H2O2, it gives 2Az plus H2O plus O2. Right. So this is reduction. Next. KMnO4 is decolorized by H2O2. How? This is the equation. So here manganese oxidation state is +7. Here it is +2. So oxidation state is reduced from +7 to +2. So this is reduction. Next, it reduces potassium ferricyanide to potassium ferrocyanide. Potassium ferrocyanide. So what is that? 2K3 FeCN6 plus 2KOH plus H2O2 gives rise to 2K4 FeCN6 plus 2H2O plus O2. So it reduces potassium ferricyanide to potassium ferrocyanide. Here oxidation state of iron is +3. Here oxidation state of iron is +2. So +3 to +2. Is it reduction or not? Decrease in oxidation state is called reduction. So that is about reduction properties of H2O2. Next. Uses of H2O. Uses of H2O2. 30% H2O2 is used as antiseptic. It is known as parahydrol. It is known as parahydrol, right? And one more use is used as rocket fuel. Okay. Last part in this structure of H2O. What is structure of H2O2 set? It has open book structure. It has open book structure. So this is open book structure of H2O. Okay. Then next topic is about hard water and soft water. Done. So let us move to hard water and soft water. What is hard water? What is soft water? Hard water is nothing but which does not produce lather readily with the soap. That is what we call hard water. Soft water opposite to that, which produces lather readily. That means immediately you will get lather readily with the soap. That is what we call hard water, soft water. And what is hardness of water, sir? What is hardness of water? Let us move to the topic now. Hardness of water. What is it? Hardness of water. In that first one. Hardness of water is caused by chlorides, bicarbonates, and sulfates of calcium and magnesium. So salts of calcium and magnesium. Which salts? Maybe chlorides, bicarbonates, or sulfates. So they will cause hardness of water. In that types of hardness of water, first one, temporary hardness. So temporary hardness is due to presence of bicarbonates of calcium and magnesium. Then removal of temporary hardness. Removal of temporary hardness. Okay. How we can remove temporary hardness? One simple method is by boiling. By simply boiling, we'll remove temporary hardness. Next, by adding sodium carbonate. Third method, Clark's method. This third method, Clark's method. Third one is Clark's method. So what is Clark's method actually? Add slacked lime to hard water. What is slacked lime? Calcium hydroxide. What is slacked lime? Calcium hydroxide. Just add calcium hydroxide to hard water and boil that water. So temporary hardness will be removed. Next one, permanent hardness. Permanent hardness of water. So what is permanent hardness of water? It is due to chlorides and sulfates of calcium and magnesium salts. Right? So this is about permanent hardness. Then how we can remove? Removal of permanent hardness. Okay. So how we can remove permanent hardness of water? So in that first one, with Na2CO3. So sodium carbonate can be used to remove both temporary as well as permanent hardness. Next, Kalgan's method. What is that? Kalgan's method. So what is Calgon? Sodium hexametaphosphate. Sodium hexametaphosphate. So that is what we call Na6P6O18. This is what we call Calgon. Okay, this one method. Next, permutate method. This is one more method. This is also important, permutate method. So what is permutate? So permutate is artificial geolite. So what is its formula? Na2, Al2, Si2, O8, X moles of water. So this is what we call artificial geolite. Last method, synthetic resins method. Synthetic resins method. So this is all about temporary hardness and permanent hardness of water. Temporary hardness as well as permanent hardness of water, right? So with this we completed hydrogenous compounds. Then we'll move to S block elements. S block elements. In S block elements, we have two groups. So first A and second A. Let us see first A group elements. What are they? Alkali metals. So let us see first alkali metals. So what are alkali metals? Lithium, sodium, potassium, rubidium, cesium, francium. Francium is radioactive. Then atomic number. Lithium 3, 3 plus 8, 11, 11 plus 8, 19, 19 plus 18. What you will get? 37, 37 plus 18, 55, 55 plus 32, 87. So these are atomic numbers. Then the general electronic configuration for this NS1. Common oxidation state +1. Valency, how many valence electrons are there? Only one. So this is about common, some general information about first year group elements. Then general characteristics. General characteristics. So what type of general characteristics are there? So we'll see one by one. First one, atomic size. What happens to atomic size? Always down the group, atomic size increases. So what will be the order of atomic sizes? Lithium less than sodium, less than potassium, less than rubidium, less than cesium. Right. So that is about atomic size. And order also we have. Next one is density. Second property is density. So this is also down the group, density increases. But there is only one change. there is an exception. Density of sodium is more than potassium. This is the only change. Then what will be order? Lithium. Down the group, it should increase. But this is only change. Lithium less than, potassium less than, sodium less than, rubidium less than, cesium. Done. That is about density. Next, flame test. Flame test. So if they are exposed to flame, what type of colors they will exhibit? What type of colors they will exhibit? Let us see one by one. Lithium, crimson red, sodium, yellow, golden yellow color, potassium, lilac color. Lilac means almost near to pink. Rubidium, red or violet. Cesium, cesium exhibits blue. Okay, so these are flame tests given by alkali metals. Alkali metals. Then go to next property. Hydration energy. Hydration energy. So when it comes to hydration energy, what is order? Lithium greater than, sodium greater than, potassium greater than, rubidium greater than cesium. Okay, so here there is one relationship. Hydration energy is inversely proportional to ionic size. This is inversely proportional to conductance. So that means more the hydration energy, low will be its conductance. More the hydrogen energy, that means its ionic size is less. Okay. Next, chemical reactivity of alkali metals. The first one, with oxygen. Lithium forms monoxide. That means Li2O. Sodium is more favorable towards peroxide. That means Na2O2. Then potassium is more favorable towards superoxide. KO2, potassium, rubidium, cesium. So that means down the group, the ability to form superoxides increases. Okay, this is about chemical reactivity. First one with oxygen. Next, hydroxides. Basic nature of hydroxides increases down the group. That means basic nature of lithium hydroxide is less than, sodium hydroxide is less than, potassium hydroxide is less than, rubidium hydroxide is less than cesium. So highest basic nature is cesium hydroxide. Next one, halides. So what type of halides they will form? NaCl, NaI. That means MX type. Example, NaCl, KCl, like that. Okay. Only one point you need to remember, thermal stability of these halides increases down the group. So down the group, their thermal stability will increase. Next, sulfates. Only one question they are asking. Solubility of sulfates. What is the order of solubility of sulfate? Lithium sulfate is less soluble than sodium sulfate, then potassium sulfate, then rubidium sulfate, then cesium sulfate. So who is more soluble? Cesium sulfate. Next, solubility in liquid ammonia. So these metals, alkali metals, are soluble in liquid ammonia and forms blue colored solution. Okay. Now, this blue color solution is good conductor of electricity because it produces unpaired electron and paramagnetic in nature due to the presence of unpaired electrons. Right? So that is about solubility in liquid ammonia. Next part, some important compounds. In the first one, NaCl. What is the first compound? We are discussing sodium chloride. Directly I'm giving you uses here. It is used as a preservative. It is used as preservative. What we can preserve? We can preserve pickles, meat, and fish. Next, it is used for making freezing mixture. Mixture with ice. Next compound, NaOH. This is known as caustic soda. So it is prepared by Nelson cell method. Nelson cell method. This first point. Second point is prepared in Kastner, Fellner method also. Castner color means electrolysis of brine solution. Electrolysis of brine solution. Right? Uses. It is used in the manufacture of soap, dyes. Dyes means colors. And in paper industry. Next, it is used in petroleum refining. Next compound, NaHCO3. It is prepared by Solvay process. Okay, and where it is used? Uses in the preparation of, is also known as baking soda. It is used in the preparation of baking powder. Next, it is used in fire extinguishers. And is used as antacid. It is used as antacid. That is about sodium bicarbonate. Next, Na2CO3, sodium carbonate. Okay. Now Na2CO3, 10H2O. This is known as washing soda. Okay. As usual, users will deal for making fusion mixture. Fusion mixture. That is Na2CO3 plus K2CO3. Next, in softening of water. That means conversion of hard water into soft water. Next, in the manufacture of glass, caustic soda, and in soap. So these are different compounds formed by alkali metals. Last part in this chapter, S block elements, it is second A group elements. Okay, so they are called alkaline earth metals. So let us see elements. What are the elements? Beryllium, magnesium, calcium, strontium, barium, radium. Beryllium 4, 12, 12 plus 8, 20, plus 18, 38, plus 18, 56, plus 32, 88. What is general electronic configuration? NS2. common oxidation state plus 2. Valency 2 means valence electrons. Then general characteristics. The first one, as usual, atomic size. Down the group, atomic size increases. Then what will be the order? Beryllium is less than, magnesium is less than, strontium is less than, barium. Okay, next. Density. So only one exception, density of magnesium is more than calcium. So what will be order? Calcium less than, magnesium less than, beryllium less than, strontium less than, barium. Next, flame test. Beryllium and magnesium, no color. Calcium gives brick red. Strontium gives crimson red. Barium gives apple green. So that is about flame test. Next, hydration energy order. What is hydration energy? Always hydration energy decreases down the group. So first one will have more hydration energy than magnesium, calcium, strontium, barium. Right? These are general characteristics, right? So now we'll move to chemical reactivity, right? Just 1 minute, I'll start chemical reactivity. Okay, let us move to chemical reactivity now. Chemical reactivity. In that, first one, with oxygen. With oxygen, they will form MO type oxides. What are MO type oxides? Beryllium oxide, magnesium oxide. M may be, here M is any alkaline earth metals. Okay. Barium oxide. But this beryllium oxide shows amphoteric nature. Shows amphoteric nature. Okay, next one. Hydroxides. What are hydroxides? As usual, down the group, basic nature of hydroxides increases. That means beryllium hydroxide is less basic than magnesium hydroxide is less basic than calcium hydroxide. It's less basic than strontium hydroxide, less than barium hydroxide. Again, this beryllium hydroxide, it is amphoteric. Next. Metal carbonates. Metal carbonates. Now, order of stability. Metal carbonates. Order of stability. Beryllium carbonate is less stable than magnesium carbonate, then calcium carbonate, then strontium carbonate, then barium carbonate. Okay. Then sulfates. As usual, order of solubility is important. Order of solubility. Down the group, solubility increases. So Li2SO4 is less than, beryllium, these are alkali metals. We are doing alkaline earth metals, right? Alkaline earth metals means beryllium sulfate is less than magnesium sulfate solubility, than calcium sulfate, than strontium sulfate, than barium sulfate. Okay. Next, let us see compounds of alkaline earth metals. In that, some important compounds we'll discuss. First one, calcium oxide. It's also known as quicklime, CaO. It is obtained by calcium carbonate. Upon heating, decomposes to CaO and CO2. So this is what we call limestone or marble. Okay. Next compound, calcium hydroxide, CaOH taken twice. This is also known as slacked lime. Slacked lime. Right? One important point we need to discuss here, that is when slacked lime, that is calcium hydroxide, if chlorine gas is passed through slacked lime, then you will get CaOCl2 plus H2O. So this is what we call bleaching powder. So bleaching powder is obtained by passing chlorine gas through calcium hydroxide. Next, calcium carbonate is also called limestone, marble. How you will get calcium carbonate? When slack line is treated with CO2, then you will get calcium carbonate plus water. So this is our target molecule, CaCO2. Next, gypsum. What is gypsum? Calcium sulfate dihydrate, 2H2O. Then plaster of Paris. This is calcium sulfate hemihydrate or semihydrate. Hemihydrate or semihydrate. Okay. So this is all information about alkali metals and alkaline earth metals, right? So now let us move to some question solving session. So let us see some questions. Ionic conductance of chlorides of group 1 is in order. What is that order? So this is order options given. LiCl is less than, NaCl is less than, KCl is first option. Second option, LiCl. Third option, NaCl is coming forward. Last option, KCl greater than, NaCl greater than, rubidium chloride greater than, lithium chloride, and cesium chloride, right? So this is a question about ionic conductance, slightly application oriented. Slightly application oriented. So the relationship you should remember here is, this is, I'm giving you shortcut method to identify answer for this. Smaller cation leads to low ionic conductance. Smaller cation leads to low ionic conductance. Means smaller the cation, lesser will be its ionic conductance. Who is small cation here? So Li plus is less than, Na plus is less than, K plus is less than, rubidium plus cesium. So who is least size? Lithium. So this will be your order. LiCl should be less than, NaCl should be less than KCl. So first option is your answer. The answer should be first option. Right? Next question. Which of the following alkaline earth metal alkaline earth metal is strongest reducing agent. Options: calcium, strontium, barium, magnesium. Okay. So what is general trend? I'll give you general trend, then you tell me your answer. The question is about strongest reducing agent. Down the group, reducing ability increases. Down the group, reducing ability increases. Okay. So that means who is down the group? Calcium, strontium, barium. Who is last element? Barium. So it will be strong reducing agent. Next, similar model. Which of the following alkaline earth metal hydroxide is strongest base? Same model. Which of the following alkaline earth metal oxide? Alkaline earth metal hydroxide is strongest base. So options given are beryllium hydroxide, B, magnesium hydroxide, C, calcium hydroxide, last one, barium hydroxide. What is the general trend we know? Down the group, basic nature of hydroxides increases. This is our trend, right? Down the group, basic nature of hydroxides increases. So who is down the group? Which element is present? Barium hydroxide. So barium hydroxide will have more basic nature. More basic nature. One interesting question. So let us see that question. In India, at the occasion of marriages, the fireworks used, we know that we'll use some fireworks, crackers, right? Fireworks used give green flame. Which one of the following radicals may be present? Which one of the radicals may be present? Options are sodium, next potassium, calcium, and barium. Sodium, potassium, calcium, barium. So which gives green color flame test? Already we have seen flame test, right? Where is that? So green color, here you can see. Who is giving green color here? Apple green, that is barium. So do we have barium option here? Yes. So this is a correct option. Barium will give you apple green colored flame, right? Next, one more question. Sodium metal cannot be stored under benzene. Can we store sodium in benzene? Or kerosene? Can we store sodium in kerosene? Third, alcohol. Fourth one, toluene. So where sodium metal cannot be stored. Sodium cannot be stored in alcohol. This is polar in nature. So polar solvent. So we cannot store sodium in polar solvents like alcohol, water. Water is also porous. So because it will explode in polar solvents. Whereas benzene, kerosene, toluene, they are non-polar solvents. They are non-polar solvents, right? See some questions from hydrogenated compounds also. The adsorption of hydrogen by metals is called, what is that phenomenon called? Options given: dehydrogenation and next one, hydrogenation occlusion deadsorption. So the adsorption of hydrogen by metals, that is occlusion. Hydrogen gas adsorbed on palladium metal surface. That is what we call occlusion of hydrogen. Okay. Next, the gas used in hydrogenation of vegetable oils. Vegetable oils in the presence of nickel as catalyst. So which gas is used for hydrogenation of vegetable oils to form dalda or vanaspati? What you will get finally, dalda or vanaspati. So methane, ethane, ozone, hydrogen gas. So hydrogen gas is used in hydrogenation of vegetable oils. Next question. when same amount of zinc is application oriented question. When same amount of zinc is treated with is treated separately. Is treated separately with excess of sulfuric acid. With excess of sulfuric acid. And the second case is it is treated excess of NaOH. Then, now the question, the ratio of volumes of hydrogen evolved is. Options given are 1:1, 1:2, 2:1, or 9:4. Now let us consider those two reactions once again. Zinc treated with H2SO4. Now it will get zinc displaces H2. Then it gives zinc sulfate plus H2. Next, zinc treated with excess of NaOH. Then what you will get? Na2ZnO2 plus H2. So, what is that ratio here? This is 1 mole, this is 1 mole. So, what is ratio? 1:1 ratio. Here 1 mole of hydrogen, here also 1 mole of hydrogen. Then what will be the ratio of hydrogen gas evolved? 1:1 ratio. 1:1 ratio. Next, one more question. Which are the following cannot be oxidized by H2O2? Options given are ozone, KiNHCl, C, PBS, D, sodium sulfide. So correct option here is hydrogen peroxide cannot oxidize ozone. It cannot oxidize ozone. Next question. Among is based on hydrides. Calcium hydride, ammonia, NaH, and B2H6 diborane, which are covalent hydrides. The question is about covalent hydrides. Options are NH3 and B2H6. Next option, NaH and CaH2. Third option, sodium hydride and ammonia. Next option, calcium hydride and B2H6. Right? Now, we need to find out covalent hydrides. Okay. So what is the generalization? Covalent hydrides are formed by 13th, 14th, 15th, 16th, and 17th group elements. They're all covalent hydrides. So among them, which elements are belonging to 13th and 14th, 13th to 7th, they will be considered as covalent. Let us see first option. What is that? Ammonia and diborane. Now in this ammonia, which group? 15th group, boron, 13th group. So these both are belonging to elements which can form covalent hydrides. That means 15th as well as 13th group elements are able to form covalent. So both are covalent. So first option itself your answer. Right. Then one more question we'll see. The velocity of neutrons, in nuclear reactor is slowed down by, means the reactivity is decreased. Options: D2O, H2O, zinc rod, and fused caustic soda. Fused caustic soda means NaOH. Okay, so then which can reduce the speed of neutrons, So generally, heavy water is used as this. Heavy water is used as moderator in nuclear reactors. Right? So these are some important questions. Tomorrow we'll see 13th group and 14th group. Right? So that's it for this session. Meet you tomorrow. Good night, all of you.